Lunar dust is acknowledged as one of the biggest engineering problems for anyone building on the moon. It is razor sharp, electrostatically charged, and it gets into everything, including your lungs, and it's not nice. The obvious solution is to go underground. But here's the problem. Nobody has ever seen what is below the dust layer. We know there is something. We call it the Megaregolith, but we do not know how thick it is, what it looks like, or whether the dust problem simply follows you down. What is Megaregolith?
What is Megaregolith? All right. So, and again, I don't consider myself a selenologist, a lunar geologist.
Me neither, so we are on equal
Right.
footing there.
But I have done some research on it. And so the major factor that created a lot of the geology on the moon is impact gardening, right? It's impactors, right?
Yeah,
So
I agree.
the early moon got hit by a lot of big high impact rocks, and it created big crater, the basins. Like it created the basins first, which are the big impacts, and then as the frequency decreased and the overall impact energy started decreasing, those basins started getting filled in, and then the larger craters started getting filled in, and then so the moon is a bunch of layers basically based on impacts, because an impact hits, it digs out a crater, but it also throws all that material out, which then buries other craters. And then another one impacts and it throws material into that other crater. So it's just craters filling in from other impacts.
Well, yeah,
And
I
so,
agree with that.
okay, so and eventually the impacts, the big ones stopped. There just wasn't enough material left in the solar system to hit the moon. So then it was medium-sized impacts, and those were all gone. And then today we're basically left with micrometeor impacts, really small stuff hitting all the time, basically. And that is where you get to the real gardening, where it's just churning over that top layer because they don't have enough energy to punch deep anymore. So they break up the top layer, they fuse stuff, they break up the fused stuff, which are called agglutinates, and you end up with this fine powder at the top. And
Yeah.
so it and we have samples from this, right? Right. The Apollo returned a bunch of core samples that got, like, I think, meter and a half, 2 meters deep. So we can see that there's a gradient of really fine dust at the surface, increasing in particle size as you go deep. And from what we've seen from the seismic survey that Apollo did, we think that that gradient continues as you go down. So,
Yes, I agree with that mostly, but I have a couple of points where I disagree.
okay, well, let's let you do that, and then we'll go on to the next thing.
Uh, so the first one is that you said it first was big meteorites, and then they ran out, and the medium ones came, and then they ran out, and then the fine ones come. I think it has all the time been a distribution, and the
Well,
distribution as such is still pretty much the same. Is my view. And that means that there was more fine meteorites as well early. It was just that everything went faster at that time.
I don't think the distribution is the same. We haven't seen a large impactor in a very long time on the moon. So the distribution has changed from, yes, there's always been small and mediums mixed in with the large, but impactor size has definitely decreased over lunar time. Just because
Yeah, yeah.
because all the big ones got swept up by other planets and stuff. There just wasn't a lot left after a certain time. I mean, those formed the basins on the moon. And those basins have then been covered up by other craters and lava flows, which means that sequentially in time, the basins were formed first by the really large ones, and then there weren't any more really large ones. And then it was large ones, and then medium ones. And then even those stopped really happening. And you can see it because the surface of the moon, the big ones get buried by smaller and smaller craters.
Older ones get buried. There are new, reasonably big ones. There aren't many, but there are.
I'm
And
not saying it's impossible.
I do think the sweeping up mechanism it acts very much the same for small micrometeorites as well as for big ones. They continue in a trajectory, and the trajectory is essentially independent of size because gravity is independent of size. So I do believe that there was quite the same ratio of big to small uh, in the early days as it is now. It's just that now there is less of all the sizes, and the large ones were obviously fewer than the small ones, and they are still. So it's very rare that we have a huge meteorite coming through the vicinity, and even rarer that it actually hit something.
Yeah, because most of the big stuff got either put into a stable orbit or got swept up by larger objects or got
Yeah.
ejected from the solar system. You know, that's as far as I understand it, that's pretty much the prevailing theory is that during the early solar system there was a lot more material out
Yes.
there and that
There
it
was a
all either got swept up, ejected, or stabilized.
There was a lot more material, but I think the material, and there was, but and obviously the smaller, finer particles, there are much more of those. So what we're seeing now remaining is the long tail of what was earlier a huge fraction, the same fraction being fine material. It's just that now it is so few, so sparse, the entire population that we don't see the big ones because they might come at an average in a billion years. I don't know, just guessing something.
Okay, I don't know. That's I'm just telling you
There,
what
there,
I've read, and that's basically my understanding of it. Is that the point is that when we're talking about the Megaregolith, which was the topic,
yep.
at some point the big ones stopped hitting, and they stopped punching deep, and they stopped shattering bedrock, and so now you're starting to get a layer of undisturbed shattered bedrock, and that's the Megaregolith. Because
Yep.
above the megaregolith is a layer of regolith, which is much finer particles. As you go down in the regolith, the particle size increases, and there isn't like a
It's a
defining
gradient, yeah.
factor. There isn't you can say, oh, this is the line between the regolith and the
No,
megaregolith. It is a gradient of increasing particle size and decreasing decreasing amount of fine particles. The further down you go, you're going to get bigger and bigger
that
boulders and
that
less dust.
that is the one part that I don't think there is any documentation of, that there is a decreasing amount of fine particles, except that obviously if there are more bigger particles, then there is no fine particles where those are. But in between, it's perfectly
Yeah, but for a
possible,
certain,
and I think it's even likely that there is. So I think all the spaces is filled with fine dust. That's my
but you have less and less spaces the further down you go because particle size increases.
That is
So you have
true,
less
but it's still
voids,
way
less
too
spaces.
much.
Well, that is an undetermined thing because we have never physically seen the megaregolith. The only time we can see the megaregolith is in crater walls that punch deep enough to get down into it. And even those have been filled in over time. So we very rarely get to actually see what the megaregolith looks like. And we haven't sampled that far because even in the mare, which is where the regolith is thinnest, you're still talking meters to get down to the megaregolith.
Yes.
So,
I agree on that. We don't really know. I still think that wherever you are that has any type of contact with the surface, even through boulders, there will be the fine dust as well. So I think it's very difficult to get. out of that,
Well,
and
it
it
may
will
it may
fall.
be. It may be that, you go down 10, 15, 20 meters and you're still running into some of the fine dust. But it is guaranteed that it will not be at the same concentration as the surface because the surface has been gardened for a very long time and it has centimeters, if not meters thick of much finer stuff the further you go down. So the top is going to have the highest concentration of the fine stuff, which is the worst stuff. Just by definition, it has to because it has been exposed the longest to the impact gardening, so it has created the most amount. If the moon was still getting hit by large things that were churning over the surface, it would be a different matter, but it's not. And as you
The
go further down, particle size increases, which means that the amount of fine stuff has to decrease in a certain volume, in a given volume, as you go down. Because at some point, around 2 kilometers, we think that you start getting out of the fractured bedrock and into real bedrock.
yeah, that's a kind of that's probably academic for the foreseeable future. Getting 2 kilometers down is tricky, even on the moon. It's
There's
easier on the moon because of the low gravity. But then again, it's more difficult because the bedrock is already fractured.
Yeah, well, I mean that's yeah, again, it's a gradient, right? Like, at the surface, it's fine dust, and as you go down, it's bigger and bigger particle sizes, and then you start getting into, you get boulders, and then you get bigger blocks, and then you eventually get to the point where it's mostly just fractured bedrock, right? It's not even boulders at that point; it is just fractured bedrock, and then you get down to where it's solid bedrock. And it's all a matter of energy, right? Like the really big impactors shattered bedrock deep and far and created this fractured bedrock megaregolith.
Yeah, yeah.
But when
And
they
then
stop
now,
coming,
and that is a difference actually. I don't. I think it's just going slower, and I do believe that. But except for one important detail, and that is that now there is a lot of regolith. So anything hitting the moon now doesn't hit bedrock, it hits regolith. And then, in order to do damage to bedrock, it needs to penetrate through uh, a bucket of dust and boulders.
yeah, well, that's the thing, most of the stuff that's hitting now isn't large enough and doesn't have enough energy to punch through the regolith. So all it does is churn that layer of regolith and make even more dust. Very rarely does it have enough energy to punch into the megaregolith, and even more rarely does it have enough energy to actually start to impact the bedrock underneath the megaregolith. Those kind of impacts just do not happen. I mean, they could. Who knows what's
Uh,
lurking out there? But
uh,
it's been a very
uh,
long time since the moon's been hit that hard.
Sure about that. There are some pretty recent craters, and if you look at even the Apollo landings, there are boulders at the surface.
Well, yes. And of course, there are exceptions to everything. The moon is not a uniform place. So you will have places where particle size is higher because of whatever happened, and you'll have places where there's more dust. So yes, there are boulders. They're not huge boulders in relationship to what we think might be buried deeper in the megaregolith. They're the size of maybe a house, which is still big, but it's
Yeah,
not. It's they think that some of those bigger impacts threw much larger blocks out of the crater. So those are probably the
probably.
result of something, a mid-size impact, which may or may not have affected the bedrock. It still has to have enough energy to punch down 2 kilometers. It's a lot of energy.
Yeah,
I think I read somewhere that the last big impacts were the ones that might have been on far side, but it caused the mares to form. It actually, the impact pushed the magma out into near side.
Mm. On the creep region. It's not
Yeah.
it.
Yeah.
That's
Again,
why we have creep on the near side.
yeah, that's right. That's why there's creep on the near side because that magma got pushed out of the core and formed the mare. Um, but that was a long time ago too. So,
Yeah.
and if you look at the mare do not typically have very large craters. And the mare are the newest geological feature on the moon.
They also have a thinner layer of regolith overall. Yeah.
Right, because they haven't been exposed to the impact gardening for as long as the highlands have.
Mm.
Because the highlands have regolith that could be tens of meters deep. Again, we don't really know. I think the Chinese did a some kind of survey using radio or radio waves or something. I don't know, but I think they created a profile for where their rover was going, and they showed that the regolith was tens of meters deep as opposed to,
Yeah.
meters or maybe 10 or 15 meters deep in the mare.
Yeah, I think I read somewhere well, 3 to 5 meters in the Moran and above 15 in the Highlands.
Yeah, I mean it's very variable, right?
Yes.
It all depends, but yeah, I mean the general consensus is that the highlands are significantly deeper. The regolith is deeper or thicker than in the
Yeah.
mare, just because the
Yeah.
mare is younger.
Yeah.
So
And of course it varies, and we don't know much. Yes.
we don't. We have literally a handful of core samples, and none of them got below 2 meters. So, and they were all very difficult to obtain, and probably weren't the most precise, right? I mean, they really had to force them to get them in down to that depth, and probably compacted the core sample a bit. So, yeah, but they're the best we got. And the seismic survey from Apollo was a nice attempt, and we got some data, but it really was not what we need. So,
Yeah, the Chinese is probably more both deeper and more accurate and higher resolution
yeah, I don't know really how
because
they
it's
got.
more modern.
Yeah, probably. I don't really know much about it, but I remember seeing a paper where they had a little image and they showed the breakdown of the layers.
Uh,
So,
that kind of images has been around for a long time, though. You don't need accurate data for that. I can draw one.
yeah, well, that's true. And I didn't dive deep into it, so I don't know about the validity. I'm just telling you, I just read a paper that had a picture. So,
Yes, yes, yes. There are nice pictures about it.
yeah.
Maybe that's a good time to stop there. I think we have had a good discussion there. We kind of agree in the broad sweeps. Possibly not in the statistics of it, but that's a different story.
Well, I think that we just won't know until we go, right? I mean,
Yeah,
we need to get if we're interested in the Megaregolith, which is what I was looking at, was the Megaregolith, because the regolith, another topic, is terrible. It's got all kinds of disadvantages. So getting below that would be a good idea. But yeah,
down to
we
down to several kilometers deep, or
no, just get below that layer of fine stuff at the
okay,
very
down to the not down to the cracked bedrock. Yeah.
yeah, down to the cracked bedrock. And
Yes.
then you probably won't get away with getting away with all of the fine stuff, but it will be a lot less the deeper you go. Just has
Yes.
to be because particle
Because
size
there
increases.
because there are more of the other stuff. Yes, I
Yeah.
agree on that part.
So, but that's going to require actual excavation on the moon, right? To actually find. I mean, we're not going to get a real core sample that deep. We're going to have to dig to actually find out what's going on.
Yes, or then again, we might want to avoid digging and go directly into bedrock somewhere on the crater wall, or
I don't, I read a few things about the crater walls, and I think the idea is that That's fractured bedrock too. I mean, it's all been
Yeah, yeah.
shattered by the impact.
Yeah, yes,
So,
yes, yes. It's Megaregolith. It's not
yeah.
solid bedrock as
But
such.
you're right. We could go at it from a crater wall, and it would have a much thinner layer of regolith over a crater wall than on the surface. So, yep. If you wanted to get into the mega regolith, maybe, well, there's always a layer of regolith, fine regolith everywhere on the moon almost.
Yeah, but you will have to. There will be cracks in the Megaregolith, and they will be filled with finer dust.
Well,
So
sure, but I'm just
there,
saying there's also a layer.
getting into it, you will encounter the occasion a fair bit of fine dust, I think,
Yeah, until you get
regardless of how
past
you
it.
do it.
Yeah.
Then again, starting to dig in the fine dust and trying to get down to the Megaregolith through dust, that's asking for trouble, I think.
It is, but it's a lot less trouble than some of the schemes where we're moving millions of tons of regolith to extract stuff. That's going to create a big dust problem.
Yes, then we need to find out a way of doing that in a controlled manner.
Yeah, that'd be interesting.
Yeah, that's a topic for a different time, I think.
Yeah.
And probably a topic for a different time is how to construct a shelter or the colony. There are a few different versions on that.
Well, you're talking about surface versus underground.
Yeah, and tipping over a starship is the most popular one now, and then
Mhm.
covering it with a couple of decimeters of regolith, and then sometimes they actually say it, and it has to be at least 5 meters somewhere a bit in, but the pictures that's not what the pictures say.
And then we're back to moving around a whole lot of regolith, which is going to create a
Yes.
dust problem. So,
It's
yeah.
probably easier to dig down, put the starship down than to put regolith on top of.
I mean, honestly, it'd probably be easier, you're right, to dig a trench and put it in a trench and then bury it versus
Yeah.
trying to pile up meters because, regolith has an angle of repose that it likes to be at. Another, if you
Yes.
move it, it tends to just flow away from where you want it to be.
Yes, I suspect if you're actively moving it, that angle of repose will be rather shallow. If you spend an effort piling it, it might be steeper, but that's a different story.
Yeah, there's a whole section in the Lunar source book that talks about the angle of repose. And, we have a vague idea of what it is, but what we've seen has been regolith that has been in situ for a very long time. And the
Mm.
moon experiences a lot of quakes. So, when particles are shaken, they tend to fill in to a point where they become denser and stable.
Yeah.
So that angle of repose could be for a much denser version of regolith than if we're moving stuff around and it's all light and fluffy. That might have a lower angle of repose. So
Yeah. Yes,
yeah, so that will be interesting. We do not really know the mechanical properties of regolith in situ.
there's very few vacuum tests of regolith on Earth, I think. There
Yeah,
probably some.
I'm sure there's been a few. I mean, they're very small scale, and making lunar regolith simulant is incredibly difficult to do because it's hard to simulate the conditions that created the regolith in the first place.
I think if we're gonna do angle of repose experiments, we need to have real lunar regolith because
In a vacuum,
the way that's fractured and the way it's electrostatic and
I mean, we really need to do it in situ, right? That's where we're going
yes,
to learn the most because it's got not only does it have to be realistic simulant, it has to be in a realistic environment with vacuum and all, and it's just hard to simulate that on Earth.
yeah, you could simulate a vacuum. You can get a pretty decent vacuum. We can get to back down to at least Mars standard of vacuum atmosphere. Sorry, but Moon standard. I don't think we get anywhere close that on Earth. But
If we do, it takes a lot of energy and it's small, right? You can only You can only do it in a
Yeah.
certain volume. You can't like
Yes.
dig a big room and get a bulldozer in there and play with it. So
Yeah, and then of course you have the lunar moonquakes as well. That might be
Mhm.
difficult to simulate in a lab environment.
We should definitely talk about those because though I don't think moonquakes get near enough attention when people talk about settlement because that is some engineering variables that are kind of important when you're building on the surface or under the surface.
Yes, quakes are important regardless.
Yes. Yeah.
There are means to cover that, of course, but that's
We'll
uh,
talk about quakes in another
well,
episode,
yes,
in another
yes,
ramble. Yeah.
yes. I think that was a good one, and I think we have done. We have been rambling long enough now.
I think so.
Before you can decide how to build on the moon, you need to know what you're building on. Right now, we are just scratching the surface.